in applied. So I don't think I need to do too much. And actually, permutations and combinations are both done through that applied course. So it's basically going to be a review for us as to how we do it. So the first thing that you need to remember is we have n factorial. So that's like saying n times n minus 1 times n minus 2, and so on.
Can you tip your camera up a little bit?
Up?
Yeah.
Is that better?
Yeah.
Okay. So I get to 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. All right. So that was the first thing. A permutation. NPR is n factorial over n minus r factorial. Okay, and what we have to remember about that is that order is important. So anytime that you are asking for a specific order, you're using a permutation. So if you're asking for a president, a vice president, and a secretary, and how many ways can you do that? That's a permutation. Okay, if you're arranging 5 people or 3 people from a group of 5, that's a permutation, 5p3. All right. For permutations, well, they also talk about repetition. So when we used repetition, we talked about this. How many ways can you arrange the letters of the word seam? Well, 4 factorial. We put 4 blanks. You have a choice of 4 letters in the first one, 3 in the second, 2 in the third, and 1 in the last. So that was 4 factorial ways of arranging the letter C. It changes when I have repetition. I have repeated letters. So to get that, I take 4 factorial, which is what we have, the number of letters, and we divide it by the number of like terms. Some of my eye here. All right, so I divide it by 2 factorial. Okay, so that was with like terms. That pretty much covers your key ideas. Okay, so let's look at example 1 on page 364. A school cafeteria offers sandwiches made with fillings of ham, salami, cheese, or egg on white, whole wheat, or rye bread. How many different sandwiches can be made using only one filling? Okay. So the first thing that you want to do is it says how many different sandwiches can be made by using only one filling. So and you have to choose the filling. So on the first one there are ham, salami, cheese, or egg. 4 ways to do that. And whole wheat, white, or rye bread, 3 of those. So there's 12 different ways if we select one bread and one filling to solve for it. Now we also said that we could use tree diagrams, and I think you're going to use the tree diagram in the combinations a little bit more than you will in the permutations. But a tree diagram. So first thing you do, choose your filling. So that's what was it? Salami. Ham, salami, cheese, ham, salami, cheese, or egg. And then you've got white, brown, or rye bread. White, brown, rye bread. Count all of those up. There's 12 ways in which we can select that sandwich. Okay. This is what we refer to as the fundamental counting principle. When it comes to permutations, and it's probably the easiest way to do it because all you need to do is put the blanks in and then put the number of choices you have in each blank. Okay, so that's A. B, in how many ways can 5 black cars and 4 red cars be parked to each other in a parking garage if a black car has to be first and a red car has to be last? Okay, so I have a total of 9 cars. So in the first one, I need a black car. So in this course, they were more specific as to how to explain your answer. So I put a black car here. I have a choice of 5. Over here, I have a red car and I have a choice of 4. Okay, so that's the start of this. So I have 5 and I have 4. All right, and then there's no other specifics about it. Okay, so because I can't, sorry, go ahead.
I need to run outside quickly. I'll be right back.
So I have to look at it and I have to say, can I tell the difference between them? And if I can't, then I would have to divide. All right, but in this case, all the cars are different. So use the numbers you've determined to fill in the blanks that represent 9 cars parked in a row. By the fundamental counting principle, there are 5 black cars. I'm just following on page 366. There are 5 black cars. There are 4 red cars. After filling the end positions, there are now 7 positions to fill with 7 cars remaining. So basically, you have that. All right. We had 9 cars to start with. So there would be 9 blanks. The first blank has to have a black, the second blank has to have a red, and then everything else in the middle there doesn't matter. So I have a choice, and this I multiply, and that tells me the number of ways in which I can park those cars. Okay, so it says use the numbers you have determined to fill in the blanks that represent the 9 cars parked in a row. By the fundamental counting principle, there are, and so we multiply 20 times 7 factorial, and we come up with our solution for that question. Okay, again, I'm going quick. If you guys need me to slow down, let me know. But this is just review. Evaluate 10p6. So on your calculator, if you were using it, you'd go into the math probability part, math, and then find permutation. However, 10 factorial over 10 minus 6 factorial is equal to 10, because the bottom's 4 factorial, you cancel them. So you're left with 10 times 9 times 8 times 7 times 6 times 5. So one way or the other, you're using your calculator for that question. All right. Show that 20 factorial subtract 19 factorial add 18 factorial is equal to 362 times 18 factorial. All right. 20 factorial minus 19 factorial plus 18 factorial. I think that's what it is there. Okay. So what I'm going to do is factor out an 18 factorial out of here. So this is going to look weird. So that leaves you at 20 times 19 minus 19 plus 1. Okay? If I break this down, this is 20 times 19 times 18 factorial. This is 19 times 18 factorial. Factor the 18 factorial out. What am I left with? 380 minus 19 is 361. Add 1 is 362. All right, that's new to you. We didn't do anything like that in the applied course. The next one we did do in the applied course, I've got NP2 equals 120. So that's n factorial over n minus 2 factorial equals 120. So I break down the one that's larger. So in this case, it's n minus 1 times n minus 2 factorial over n minus 2 factorial. Okay? Those cancel. So I'm left with n times n minus 1. equals 120. So now, what I'm saying is, what are two consecutive numbers that I multiplied to give me 120? Oh, sorry, this should have been 110. My bad. Wondering why that was that. So that's 110. Okay, so what are two consecutive numbers I multiply to give me 110? Well, we can do the answer. The answer should be 11 and 10. How you would do it is you go n squared minus n minus 110. N is equal to 11 and minus 10. And we can't have negative factorials. So that means that negative 10 is an extraneous root. So the solution would be 11 times 10. So in that question, 11 would be the answer for my n value. So 11p2 would give you 110. Example 3. Number of ways of arranging the letters of the word basketball. So count the letters in basketball. 3, 4, 5, 6, 7, 8, 9, 10. And divide that by the number of repeated letters. So the A's are repeated, that's 2 of them. The B's are repeated, that's 2 of them. The L's are repeated, that's 2 of them. So I divide by 2 factorial, 2 factorial, 2 factorial. And then I would probably use my calculator at this point to solve it. So that's like 10 factorial divided by 8. And whatever that is on your calculator. Okay. Again, that was something that we've done before. Using cases to determine permutations. In how many ways can 8 basketball players sit on a bench if either the one center or both of the 2 forwards must sit at the end where the coach always sits? Okay. So, in how many ways can 8 basketball players sit on a bench if either the one center, so the center sits beside the coach, or one of the 2 forwards must sit at the end where the coach always sits? Okay, so you've got 8 players, right? So here's your coach here, and you have 8 players. If this has to be the center here, we put 1 in here. Now, how many ways can you arrange the other 7 guys? 7 factorial. Here's my coach again. One of the 2 forwards has to sit here. 2, and then again, it's 7 factorial. And if you remember, we multiply these. So this would be 7 factorial. This would be 2 times 7 factorial. And then we add those together to get our solution for the number of arrangements here. Okay. Oh, I made an error here. It says, or the 2 forwards must sit at the end. Sorry. So this one's done different. This one is both forwards have to sit here. So you have a choice of 2, a choice of 1, and then 6 factorial here. Okay, so the forward has to sit here, the other forward has to sit there. So your first choice is 2 forwards right here. And then you've got 1 forward left over, and then 6 factorial. So this would be 2 times 6 factorial, and you would add those together. Again, I'm not using your calculator. You guys can figure that out. All right. So first things first, 2 out of the 3 of you have not handed in your assignment that was due yesterday, so that needs to get in now. Where? As of what time today?
This morning.
Daylin, you're in. Mary's in. I don't have Brendan's yet.
Should be there.
No. Let's go back and check one more time. Out, in.
I have like 2 more questions to do and then she's in.
No, Brendan, yours is now in. Turned in late. Okay. Good enough. Rory, get that in today. Okay, so far, so that's that. We need to, like, look, I'm just going to shut the stream off here. It's going to be up to you guys.